This is going to be a quick video about the distributive property and a way to use a generic rectangle to multiply terms. So let's say you have the number 7 times the quantity of x plus y. So I'm going to have to multiply this amount times the number 7. So I'm going to think of this as a rectangle with the length being 7 and then the width being x plus y. I'm just going to draw a line here so I can help multiply each side. So the area of this smaller rectangle would be 7 times x, which is 7x. And then this side would be 7 times y, which is 7y. So the sum, the total area when I multiply 7 times x plus y is 7x plus 7y. The distributive property is just a way to multiply numbers when you don't know all of the numbers. And it follows along with the idea of if I did know all the numbers. So let's say I had 7 times the quantity of x, or sorry, 3 times the quantity of x plus 2. I'm just going to compare it to 3 times the quantity of 14 plus 2. So that would mean where I know what x is equal to. If I did that with a generic rectangle, I would still use length of 3 times the width. And I'm going to say it's 14 plus 2. Now I know 14 plus 2 is 16. So my solution of 3 times 16 should come out to be 48. But let's see what happens. 3 times 14 is the number 42. That's the area of that piece. 3 times 2 is 6. When I add 42 plus 6, my solution is 48. So I am correct. The area is still the same. I'm going to use that same process with this unknown. Length of 3, width of x plus 2. Oops, I messed that up. This should go above. X plus 2. And inside the area of each individual rectangle is now 3 times x, which is 3x, plus 3 times 2, which is 6. So my solution here is equal 3 times the quantity of x plus 2 is equal to 3x plus 6. You might be noticing a shortcut where this looks like if I just take the 3 and multiply it times the first term, the x, and I add 3 times the second term, I get the same solution, 3x plus 6. And that's another demonstration of the distributive property. And that's pretty much it for using a generic rectangle.